All right, Emily, we thoroughly hate you. You made fun of me, but smile pretty, kids.
Oh my God.
Anyways, I liked your international swag email. All right, so ANOVAs. It really kind of starts with your raw data, the way your raw data is set up. You know how to do a t-test. You're just comparing two groups and comparing the means between those two groups. But with an ANOVA is more robust because you can compare many things at the same time. You're running a two-factor ANOVA, which is a little bit misleading because it's better than just looking at two factors. You actually look at four factors at once with a two-factor ANOVA. Like, that's pretty much the main reason. You, on the other hand, are looking at a lot more than just a two-factor ANOVA. You are looking at, let's see here, the way it was set up, where you end up getting your data, you've got 1, 2, 3, 4 columns up top so that you can compare the Roundup, control, POIA, and glyphosate all at the same time. So that's 4 things that you're paying attention to. Now you could run, and you ran independent t-tests, one versus each one, control versus Roundup, control versus POIA, control versus glyphosate. But the ANOVA does even more than that. It compares all 3 of those at direct exposure, but it also compares them at environmental contamination and bioaccumulation, and does all of those things all at the same time. So it's like a 3x4 matrix kind of deal. So that's like the strength of the ANOVA. When you get the output, okay, this is the output from the ANOVA. I deleted a lot of it for your poster, so you don't see all this information. But in the actual Excel file, which I'll forward to you, all this information is present. It counts the number of things. So you have 20 trials. It adds all the values up. It averages them, and it finds the variance in them. And it does it for direct exposure, environmental contamination, bioaccumulation, with regards to your control, Roundup, POIA, and glyphosate. Down here towards the bottom is the actual meat and potatoes of everything. So when we see this output is what is actually on your board, okay? Or part of this output is actually on your board. The things that you pay attention to is sample, columns, and interaction. I renamed them. Sample is with respect to the rows, column is with respect to the columns, and interaction is the interaction between those rows and those columns. Now, on your original raw data, the rows were the means of exposure, and I retitled the quote-unquote sample or rows as the means of exposure on your poster. So you should be able to see that. That's what that's referring to. Is there a significant difference between the means of exposure? Does the mean of exposure have a significant effect on ACHE activity? Yes, it does. Look at your p-value. Okay. Here, just looking at your p-value, the sample p-value, 3.3 times 10 to the minus 31, extremely significant. There's a significant difference between there's a significant difference due to exposure mean, or exposure method. The next one, columns. This is just looking at the columns, all right? Your p-value here, 1.21, 1.22 times 10 to the minus 12th. That means that there's a significant difference between your columns. Your columns being control, Roundup, POIA, glyphosate. There's a significant difference between those groupings, which you already knew. You already ran independent t-tests, and you already knew there was a significant difference. But the ANOVA looks at all 4 of those things at the same time. Last but not least, the interaction. Okay, the interaction, the p-value for you, 0.0134. Okay, so there's a significant difference between the interaction of those two factors. All right. Now, those two factors are the exposure method and the chemical. So they both have an effect at the same time. That's all the interaction is saying. I think that might make sense. Next, your graph. Okay, so, well, first of all, it tells you, those p-values tell you that there's a significant difference everywhere. No matter which way you look at it, there's a significant difference between the columns, between the rows, between the interaction between the two. They're all significantly different. When I did the Anova graph, the Anova graph looks like this. Okay? We do an Anova graph with a 95% confidence interval to show you where the significant difference lies. We're comparing 4 things at once: control, Roundup, glyphosate, and POIA, all at the same time. So where does that significant difference lie? Maybe it lies in all the groupings, maybe it doesn't. So when we graph this, and this is what Palm Bay does, or similar to what Palm Bay does, they just don't know what they're talking about. You can see where the significant difference lies. Here we have our control group. They're all grouped together because they're all the same. The blue dots down here at the bottom are your direct exposure. The red dots are your environmental contamination, and the green dots are your bioaccumulation. All right. The peak absorbance, the mean peak absorbance, was the highest for your control group, which makes sense. It didn't inhibit the ACHE activity in your control group, so it is the highest. When you look at the bioaccumulation, effects due to bioaccumulation, the Roundup was lower than POIA, but it was the weakest in glyphosate, which is kind of interesting and kind of cool, because when they say that glyphosate isn't an ACHE inhibitor, perhaps that's why, because it might not be if you just looked at that alone compared to the control group. But you did a t-test and it said it was, so who cares? Anyways, the bioaccumulation and environmental contamination, the red square here, they're very close together, so they are probably not significantly different from one another. All right, but the Roundup, all right, but the direct exposure for Roundup is far below that. There's a significant difference between Roundup, environmental contamination, and direct exposure. Did I say that right? I don't think so. There's a gap here, all right, and that gap is the important part. It says there's a big difference between them, okay, and that's where your significant differences are going to lie. With glyphosate, it looks like there's almost a significant difference between your environmental contamination and your bioaccumulation dot. Okay. Pay attention to the error bars. Where the error bars overlap, that's telling you that there's probably not a significant difference between those two things. If the error bars do not overlap, like in this case, all right, it means that that's probably where that significant difference lies. Additionally, if you took a piece of paper, all right, and we lined it up, looked at your control group, all right, your control group, the bottom of your control group misses everything, okay? Here, that's the bottom half of your 95% confidence interval. 95% confidence interval says that you're 95% sure that the mean should lie between the upper and the lower hash marks on this graph. So chances are the mean will be significantly greater than the mean of any of those. The only one that might be in question is here with glyphosate, in particular the green, the bioaccumulation with glyphosate. Other than that, they're all going to be significantly different than the control group. All right. If you checked out your p-values for your t-test, look at your p-value for your t-test from control and bioaccumulation with glyphosate. I bet you that is the if anyone's insignificant, I bet you that's the insignificant one for the t-test. And if anyone is close to being insignificant, I bet you it's that one. All right, I think that's all. If you got more questions, ask them, and maybe I'll answer. All right? Have fun, be good, enjoy.